Good morning. It is, for me, early Monday morning. So we are going to be working out of this packet again. So smiley face. And we are going to turn to page 15. And we're going to talk about one kind of application problem today. So, essentially like a word problem. But these are really common questions that show up on the Algebra 1 regions in the past. So that's why we're taking a little time to focus on just these particular kinds. They're very strange at first, but once you do them, 10 times, they're basically all the same. If you do the quiz you'll start to see that pattern, and you'll feel much better about it by the end of the quiz today. And then we'll talk about it when I see you in class. Okay, so what we're going to talk about is consecutive integer problems. Consecutive integers are integers that follow each other in order. I use this word consecutive a lot. I find myself using that a lot in real life. Consecutive numbers. So let's talk about examples. Or just three, this is three consecutive integers. We're talking about three numbers in a row. So if the first number is 5, I need three consecutive. So that would be 6, 7. So three consecutive numbers right in a row. Integers, right? I'm sorry, consecutive integers. So that means we're not going to be dealing with fractions or decimals. We like integers, right? Okay, what about another set of three? How about 100, 101, 102? Three consecutive, right in a row, right in order. What are examples of three consecutive even integers? So these are just integers in a row, but they have to be even. So we're not going to do 2, 3, 4, because 3 isn't even. Okay, what am I trying to say? Alright, so we're going to do 2, 4, 6. Those are three consecutive even integers. And then you could do 70, 72, 74. I mean, we could go on and on, right? What about three consecutive odd integers? So these have to be all odd numbers. And so maybe about 7, 9, 11. Or, I don't know, 73, 75, 77. If you were in class, you'd be shouting these out to me. So I'm missing you right now. So we're going to be solving these word problems. So the sum of three consecutive integers is 42. So is 42, we got that down, right? Find the integers. So the biggest thing with these is that the let statements for odd consecutive, even consecutive are the same. And then whenever they ask for consecutive integers, the let statements for that are always the same. So once you see these problems a couple times, what I'm about to do just repeats over and over again. The sum of three consecutive integers, we're going to say let x equal the first number. So let's pretend, and it's not going to be this, but let's think of this as maybe, suppose if x was 5, right? How much bigger is the second consecutive number than the one we start with? So going from here to here is plus 1, right? So we're going to say let x plus 1 equal the second number, because it's 1 bigger than the first number. No matter what the numbers are, if they're consecutive, the second number is always going to be 1 bigger than the first number. How much bigger is the third number from the first number? Because we're always going to reference x. So let something equal the third number. Consecutive integer, you could say. So going back up here, let's just think, pretending our number was 5. How much bigger is the third number than the first number? Right, 2. So you're going to say let x plus 2 equal the... now I got 2 equals. It's early. Don't do that. Let x plus 2 equals the third number. So if we were gonna find this 42, we're talking about adding the first plus the second plus the third. Okay? So if we add all three numbers together, why is this so unfocused? If we add Mondays. All three of these numbers together is going to equal 42. So how did we say we were representing the first number? X, right? Plus, how are we representing the second number? X plus 1. And how are we representing the third number? X plus 2 equals 42. So now we have a multi-step equation. We don't have to distribute, there's no parentheses, but we do have to combine like terms. So we have 1x plus another x plus another x. So there are a total of 3 x's, and your constants combine to become 3. And so this is the equation. So on quizzes, they don't make you continually solve the equation because we know that we are level 1 experts right now. So that becomes a little tedious. So they kind of just ask you to set it up so it's not as much work. And I think it's only like 7 questions, and the last one's is a bonus. Wait till you see it. It's one of my favorites. Okay, so then you would just, subtract your constant. You get 3x equals what? 39. Divide by your coefficient, and you get x equals 13. So that means the first number is 13, second number is 14, and the third number is 15, however they want you to present that. Okay, I gotta clip it out for time here. What about the sum of 3 consecutive odd integers is 27? You have to change that for me right there. So let's talk about the first number. So we don't know the first number, so we always call the first number x. If you want to be really, really specific in your let statement, the first consecutive odd integer would be a good let statement. So let x equal the first number. These let statements become key to word problems, and there's many more word problems in Algebra 1 than there are in 8th grade. So getting used to the let statement is a really big deal. For me, it's all about the let statement. Once the let statement's comprised, the rest is usually much easier, but coming up with the let statements and making sure those are correct, big deal. Alright, so the first number is x, but if we're talking about odd integers, how much bigger is the second number than the first number? So we're going up to our odd right here. So if the first number, pretend it's not, but let's pretend the first number is 7, how much bigger is the second number? 2, and that's always the case, right? So even here, the second number in this sequence is always 2 bigger than the first if you're talking about odd integers. So we're going to say let x plus 2 equal the second consecutive integer, which I'm not writing. And then how much bigger is the third consecutive odd integer than the first one? So you can go up here and look at our examples. 7 to 11. The third number in this sequence is 4 bigger than the first number, and then obviously the same thing here. So our third let statement is going to be let x plus 4 equal the third number. Boom. Okay, so now we're going to add the first number. You don't have to write this part when you get really into it, but I'm trying to explain it. So I like to set that up so you can see where I'm getting this from. So how do we represent the first number? X. And then how do we represent the second number? X plus 2. And then how do we represent the third number? X plus 4. And the let statements are the same for odd and even. X plus 2, x plus 4. Boom, boom, all the time. So we're going to get 3x, right? See? Plus 6 equals 27 minus 6 divided by 3, x equals 7. So this is your level 1 right here. Okay? Let's do this last one. So next page, the sum of 3 consecutive even integers is 18. Okay. So what's our let statement going to look like? Let x equal the first number. And so what would the next number be? Would it be x plus 1 or x plus 2? Even numbers, and you can look at your sheet if you want to, but same thing with even numbers. First number to the second number in the sequence is 2 bigger. So you're going to still do your x plus 2 even though we're talking about even, not odd. It's because we're starting in this case with an even number and then going up by 2. So x plus 2. See, then the let statements are the same. You get points for these let statements too. And then same thing, x plus 4. The third number in the sequence is going to be 4 bigger than the first. So this will be the third number. And then you're going to do x plus 2 plus x plus 4 equals what? Is 18. So you're going to get boom, boom, boom. 3x plus 6 equals 18. 3x equals 12. Boom, boom, boom. X equals 4. Okay, so that's 10 minutes into the video. We'll save the perimeter problems. The perimeter problem showed up on the function 6 plus packet. So some of you have seen it, but a lot of you have not. So we'll do these at a later date. I want you to focus on the consecutive number problems. Really important you do the quiz is today. I need to see where in space you are with me. Like, I don't have you with me. I can't see you. I can't hear you. And I have no idea if that just made sense to you. So quizzes is super helpful. And it allows you just some exposure and some practice. Even if you get it wrong, don't worry. It's all about putting in the time and the practice, right? So have a great day. Make sure you do that. And I'll see you on video tomorrow.